Hello, good morning, happy Monday. How are you all today? Today is Labor Day in the United States, and technically is a holiday for many people. I guess now being a contractor, I don't really get holidays. It's just another day here for us. So, yay! Asitsu, hello. How are you doing today? All right. So I have experimented with the I played around with the ingrained chat systems you can see above me. I made it permanently available, so when I'm on a web browser like this, it's not super awesome. But when we're coding, I have a little column of stuff that I can use up here. And so as long as I remember that you can't see that, in fact, I mean, you can't see most of them very easily, then we're good to go. I think we'll be fine. You're doing great working on code and making steady progress. Oh, that sounds great. That's kind of what we all want, right? Steady progress. All right, so we finished updating the Axum course last time, and I had mentioned that I was going to figure out what we're going to work on next. I have sort of like a queue of things that we're going through, and one of the next sort of like item was, hey, let's do a challenge thing. Challenge would be nice, get away from all like the just projects and courses and do something fun, challenging for a while. And so I figured, hey, let's do another CodeCrafters one. Now, when I first started with CodeCrafters, before we did the Git challenge, I launched the build your own HTTP server and just went through the first one or two challenges of it. I guess the first one stage. So we're technically on stage 2. And it's just been sitting here on this page every time I come to it saying, hey, you want to finish it? I'm like, okay, that's what we're gonna do. We're gonna make this green like the build your own Git one. So that way it doesn't bother me anymore. Okay. So for those of you who were not here for the build your own Git, CodeCrafters is I've partnered with them, so they have given me VIP access to their entire site, which does mean that I have that there was a free access for it. They do have sometimes beta courses that they make available for free. So for example, they have this build your own interpreter sort of, it's not really a course, it's a challenge that you can go and do that for free right now. So if you do want to sort of check it out and try on your own, right now is a great time. Every once in a while they do like a free weekend or something else like that, but I don't see one happening right now. You're sure it will be much easier than Git? No need to decipher cryptic documentation. I hope not. But yes, it hopefully should be significantly easier than Git. Yes. As we can see, there are a lot of other things that are in here that are pretty fun. Like the build your own Redis is a lot of fun, especially now that like a lot of people are moving away from Redis and switching to other things. Sort of like to understand what exactly that means, and what do we want with that? Let's see. The other one, didn't they have a build your own doc? They had a build your own Docker, I think, at one point in time, but I don't see that anymore. So maybe that got removed. But yeah, it looks pretty cool. So I'm gonna jump into here. I did hit the reset button, so it reset the progress for us. Otherwise, it said that I had already done all the way through here. So let's see. I guess other things are, if you do enjoy this, I have on YouTube a link to CodeCrafters. That does have an affiliate sort of code on it. So if you do make a purchase with that, then I do get a little bit of kickback from it, and it shouldn't. I think we've checked it. It doesn't like increase the cost for anybody else at all. And let's see, for other things, yeah, I don't think I have anything else. So we're going to be going for we have several hours today until around, I think between 12 and 1 is when I'm going to have to jump off. So let's jump in and get right on it. So build your own HTTP server. Introduction. Welcome to the Build Your Own HTTP Server Challenge. HTTP is the protocol that powers the web. In this challenge, you'll build an HTTP server that's capable of handling simple GET POST requests, serving files, and handling multiple concurrent connections. Along the way, we'll learn about TCP connections, HTTP headers, HTTP verbs, handling multiple connections, and more. Okay, so preferred challenge assessment. We're going to go with Rust. They do have a bunch of other languages that we could choose to use, but we're going to go with Rust here. I'll say I'm intermediate. Practice cadence once a week. Accountability. Now I'll pass. Yay, we're done step 1. Repository setup. We prepared to start a repository with some Rust code for you. So we want to clone this repo. And it looks like it's going from CodeCrafters has their own Git server, it looks like. And that's what I remembered from last time is that pretty much all the fun sort of challengey validation and checking that they do is on their Git stuff, which is really cool. So let's go ahead and pull that in. Oh, that actually included the CD in there. Okay, so push an empty commit. So we want to just create an empty commit here. So git commit, allow empty, message test, and then push this to origin master. Let's go ahead and do that. And this is how CodeCrafters really works for us. Is it then runs our test and says, okay, it compiled. It is then doing the first test, and of course the first test failed, but this stage completed. How to pass this stage, which is binding to a port. Since this is a first stage, we've included some commented code to help you get started. To pass this stage, simply uncomment the code and submit your changes. So navigate to main.rs. Okay, let's take a look at what we've got here. So if we look in main, we have a bunch of this documentation. Oh, sorry, a bunch of this commented code. But we can also just look at what they have us bringing in right now. So they have us bringing in anyhow, bytes, and this error. We have found out in the Git challenge that we are allowed to bring in other things in here, and that does work. Let's see, they have their own little scripts. We're not going to worry about those. They have their README, but for the most part, we shouldn't need to worry about that too much. I believe that it is basically instructions for the entire thing, though. Oh, and then your program is a way for us to manually test what they're going to be doing later on. But okay, so let's see, you can use print statements, logs from your program will appear here. I don't think that I need this at all. So we're going to go ahead and get rid of this. Uncomment this block to pass the first stage. So what exactly is the first stage? We're binding to a port. And they don't, in this stage, you'll create a TCP server that listens on port 4221. TCP is the underlying protocol used by HTTP servers. The tester will execute your program like this. So they'll just call your program.sh. Then the tester will try to connect to your server on port 4221. The connection must succeed for you to pass the stage. Because we're not listening for anything, I wonder if they're going to use something like the old system admin in me wants to say like telnet. Is there anything more modern than telnet for like just connecting to a port? All right, let's go through this because we are uncommenting a bunch of, well, code. Let's actually make sure we understand what this is doing before we submit this. So I'm going to create a listener using TCP listener, and that is from standard net. we're going to bind 127.0.0.1, so localhost, port 4221. Okay, that sounds great. Now, if we were running this in a Docker container, let's say, then we would want to use this as like 0000. And then most likely we'd also want to have the port be something we can bring in via a environment variable. But because we are, well, right now, I'm guessing that later on we're going to want to do something like that. For right now, we're going to leave this sort of hard-coded. For stream and listener incoming, okay, so we're going to loop through all the incoming listeners. Notice that this isn't async await. We are just sort of blocking with everything. We're going to match on what the stream is, which is a result. It's going to be okay, we get a TCP stream, or we get an error. And if we get the TCP stream, we have accepted new connection. Okay, great. So what we can do is I can quit you, and we can run your program. This should compile my code and then try to run it. And I guess that's it. I took out that print line, so we can't actually see that it's working. So, okay, great. So let's go ahead and send this on up. Now, I don't believe that it matters what message we give for this. So I'm going to say we have uncommented code. That's pretty much it. And now we should see it pass this thing. Compilation successful, test passed. Excellent. So yeah, it ran our code. It connected using TCP. Success closing connection. Test passed. We got this back from it, the accepted new connection, and we're on to the next phase. Excellent. Okay, test passed. We can mark that stage as complete. Ooh, it looks like they've added that. I remember back when we were doing Git, they auto completed the stage for us as soon as we were done with it. But now they make you press a button, which kind of is nice because there's a few times that we wanted to see, hey, does it work? And then do a refactor. And that was, well, nice. Okay. Stage 2, I think. Bind to a port. No. Respond. Okay. Stage 2. Respond with 200. There we go. How to pass the stage. In this stage, you'll implement your own solution. Unlike stage 1, your repository doesn't contain commented code to pass this stage, which would be kind of strange if they just gave us the code the entire time, right? 98% of users who attempt this stage complete it. That's an interesting message. I think what they're trying to do is say, hey, don't be scared. You're okay. Almost everybody who does this gets it. Go ahead and go. It's okay. Okay, step 1. Read the instructions. All right, I'm not great at reading, but I'll do my best. The Your Task card below contains a description of what you need to implement to pass tests. We also recommend taking a look at the Code Examples tab, which contains code examples from other users. The Screencast tab, if you prefer more detailed video walkthroughs. Ooh, I think that's new. I don't remember that being there last time. Mark this step as complete once you've read the instructions and are ready to implement your solution. So, looks like these are not necessarily from them. Yeah, submit a screencast. Cool. And then code examples is everybody else who has submitted something. So for example, I think I've actually done, I did this 9 months ago as sort of like an experiment on my own. So we're not going to read my own code from back in the day. We're going to do it ourselves. Okay. In this stage, your server will respond to an HTTP request with a 200 response. HTTP response. An HTTP response is made up of 3 parts, each separated by a CRLF. So, carriage return line feed. Is that what it is? So basically, this terminology, the RN here, this comes from back in the old days when we were using typewriters, because it is possible to hit return and it would move the paper up so you're on a new line, but the print head, the thing that's going to actually punch the letter into the paper, was on the same column. So you can just create, it's easy to create more columns down. It's easy to create, like, fill out forms, do that kind of stuff. It's great, right? But if you want to go back to the beginning, you slap the little lever on the right, and then it moves it all over to the left, and then ding, and it was great. For those of you who have ever used typewriters, you'll recognize that. That has stayed with the programming community here. And so we now have to say we want to go down and left all the way. And that is the RN, is both of those together, otherwise known as the CRLF. Okay, so each separate by a so status line, 0 more headers, each ending with a CRLF, optional response body. In this stage, your server's response will only contain a status line. Here's the response your server must send. So HTTP 1.1. So, well, we're going to be responding HTTP 1.1. Okay. The 200 status code, and then the OK, which is the message that comes with this. And then we end. And then, of course, that's the ending for this. And then, of course, the very end has another one. So that's why there's 2 CRLFs here. Here's a breakdown of the response. Right, and that's exactly it. Oh, yeah, and headers go in between there. So that's also the other thing. We have OK, that, headers, which we have none of, and then end of the headers. Tests. Okay, your tester will execute your program like this. The tester will then send an HTTP GET request to your server, which is like this, the curl verbose, I want to say, to localhost 4221. Your server must respond to the request with the following response. Notes, you can ignore the contents of the request. We'll cover parsing requests in later stages. For more information about HTTP responses, see the MDN web docs and HTTP responses. Okay, excellent. So let's go ahead and get our test set up for this. Now, I don't necessarily need to write automated tests for every single one of these stages myself. I think that if we do a sort of like a manual test for this, I think we'll be fine. So let me go ahead and set up something below chat. Oh, and that's perfect. It's like a perfect spot there. So if I do it wasn't the curl. Let's copy this curl, and we'll throw that in there. So right away, I get a connection refused. So you can see that behind me. So what I'm going to do is now we're going to, well, actually, you know what? If I just run, if we run this, and I run this one again, trying to connect, we got the connection, but we shouldn't get anything. Yeah, attempted to, let's see, localhost was resolved. Connection refused because I don't actually have anything on slash. And we don't even get a 404 error because, well, we have to write that ourselves, don't we? Okay, so we kind of know that this is going to work. So we're going to have to figure it out ourselves. Let's head into main. So one of the things that we learned from the Git is the Git challenge is that we should probably start thinking about abstracting things out or moving things into other files sooner than later. And then just, if it feels nice, just like put it into its own file and deal with it there, because we end up reusing a lot of things That's what sort of like what we found earlier. And then that way we can sort of program in a more Lego mindset. Okay, so what exactly does that mean? Also, I have some neighbors are doing some construction. Can you hear any of the sawing that's happening? It feels pretty loud to me. I'm gonna go ahead and close my window. No, you can't hear it? Okay, excellent. It's like I'm glad that the mic doesn't pick that up. It's less nice though that that I can pick it up. I guess I could wear headphones, but I don't want to wear headphones. All right. So what do we want to do? So maybe we like make it work here first, and then we'll go ahead and do the next thing. Inheritane, hello, how are you doing today? We are making a HTTP server in Rust. We're using CodeCrafters as our sort of guide for this. Okay, so I have this new connection like this. Now, if I want to just say, no matter what I do, I return a 200. We can change you, and if we, let's see, how do we respond? I don't want to look at these right away. What we need to figure out is what I can do with this stream to get a response, because it's not going to be like just a return, right? It's probably going to be something like stream dot, and then I can maybe send something. So I could write something to it. Christopher, hello. How are you doing today? Are we at the beginning of the project? Yes. So we have so far, we are working on respond with 200 here. So we previously did bind to a port, which is where we got all this code. And then this is the first of the code we have to write ourselves, which is the respond with 200. What's nice is it looks like they removed the AI actual suggestions, which is nice. They do have concepts. Oh, interactive tutorials that teach you fundamental concepts related to this challenge. Oh, that's nice. If we need to, we can look through those later. So I would guess that write might be what we look for, and then we might need a flush too. So let's try a write. Takes in a self, and then, oh, a U8, but that should be fairly easy to do. So let's do our response equals. All right, now if I just hard code this. Oh, Nigel. Oh, I completely missed your message. I'm sorry about that. Nigel Ruthro, hello. How are you doing today? Is this TCP listener blocking? Yes, this is absolutely blocking here. Basically, in Rust, if we don't see an await or like an async await, or it's blocking. That's pretty much it. I am an expert at missing messages. I am. I absolutely professional streamer here with a slow chat. Yeah. But yeah, so my guess is later on when the challenge moves into concurrent requests, this is going to be either doing something with async await, but more likely doing something with threads, and maybe even creating a thread pool or something like that. It's going to be interesting to see if they suggest Tokyo or if we do something else. My guess is it's going to be just a manual threads. That's all I can imagine. But okay, so response. We need to respond back with this HTTP 1.1. So now if I copy you, so HTTP 1.1, that's our protocol. We have our 200, which is going to be our code, HTTP code. We have the message that goes along with this. That feels like this could be an enum or like a static lookup or something. We have our new lines, our carriage returns, CRLFs. And then we have this sort of space here for headers that nothing is happening in. And then, of course, body can go after that. But again, this is empty. So if I do that, and then we do a stream write, and then we have a buffer. So that's a reference to a bunch of U8s. So as bytes, which becomes a reference to a bunch of U8s. Now, as bytes, it's just as fine. And then write, what do you return? You return a result. So should we, now we have anyhow. We have anyhow, but we're in main here. So I guess for right now, I'm going to unwrap this, but we're not going to want to remain it unwrapped for long. And then let's make you mute and see if this just does what it is. Now, I haven't actually, it's been 9 months since I did this stage on my own. I've completely forgotten everything about it, so we'll just figure it out. Why did I choose to learn Rust over other low-level languages, say even C? Yeah, it's a good question. So when I was teaching, I was doing a lot of JavaScript teaching, and I was like, it's been so long since I've done anything new. Let me relearn C or do something low level. And I bought a C book. I still have it somewhere around here. Actually, I literally have it holding up the monitor that I read chat in. And I was talking to some of my coworkers, and they're like, well, why learn C again? Why not learn one of the newer low-level languages like Rust? And back then it was before 1.0 with Rust. And so I'm like, let me think about it. But I had several people who were there who knew Rust and were, very happy to be mentors for me in the learning journey. So I decided, okay, we're going to do it. I went to some meetups that were in Rust. It was the community was really awesome. And so it's like, okay, let's do it. And then I learned live on stream, going through the book. And I think I waited until 1.0 before I actually started learning properly. But that wasn't very long. It didn't take very long before Rust sort of released, as it were. So that's the real reason of why. It was because I've done C in the past, back when I was in taking college classes. And then after that, it was just access to mentors who knew Rust, because I do believe that if you're going to learn a language, having access to people who know that language also and kind of help you out is extremely important. I should put a Rust book under that monitor. It'll be the Rust Foundation. Yes, I should. I don't actually have a physical copy of the Rust books. That would work out though. Right now I have, let's see, I have a leadership book, programming in C, a random ecology book, and then a bunch of Dungeons and Dragons books. So those are all what's holding up the monitor. Okay, physical books. What are those? Yeah, exactly. They're monitor holders. That's what physical books are, right? Okay, let's see if this works the way we expect it to. So if we go ahead and we run this. This is probably an easier way of me setting this up. So we'll do your program to run you, and then you know what I'm thinking? I should do your program to run you over here. Oh, am I not in the right? I'm not in the right directory. Okay, get that going. And then over here, let's do our curl. And I believe this is what we got back out of it. So I think that works the way we expect it to. Now, theoretically, if I submit this and it passes, it doesn't like move us on to the next stage, which is exactly what we want now. So let's test that out. So if I commit and we just say responding with 200, okay. Let's find out whether or not this passes. There we go. Okay, test passed. Notice also that for every stage, it also checks this out. Write is not enough on its own. It doesn't guarantee writing all provided bytes in a single call. Oh, really? Okay. So I'll probably need write. Oh, do I need like write all or something? Or do I need to write and flush? Because I could also stream flush. Flush this output stream, ensuring that all intermediately buffered contents reach their destination. So I could do that. This is a self. There's also a write to end. I don't see a write to end. There's a write all. Attempts to write an entire buffer into this writer. This method will continuously call write until there is no more data to be written or an error of none. Okay. So this could also, yeah, write all. Okay, so let's do that. Let's do. Now, if I do write all and I do unwrap and what do I have here? Oh, it's a result of nothing. So I don't have anything more. So if I do a stream flush and we unwrap you. Now, my guess is that I probably don't need to do both of them, but if I want to be extremely sure that everything is written out before we move on to the next line, then write all and flush would probably be the best bet. So if I do this, I should probably do a cargo watch on this code over here. There's my curl. Everything here works fine. Okay, great. Now, that being said, I think that it's time for us to start figuring out a better structure for this code because everything in main is going to be kind of not great. And I really don't want to keep these unwraps here, but I don't want to have a return result on main because I don't know. Like, I know that they allow it, but I don't like it, if that makes sense. So I'm thinking we create a, let's go to source here. I'm thinking that we're going to create a library file. So just lib.rs, and I could probably throw this into there right now because I don't know the rest of like where to put this. We can probably just throw everything in here right now. Now we do need to put this inside of a function though. Duncan Stamp, hello. How are you doing today? Do I play D&D, Dungeons and Dragons? So I have played D&D a lot in the past. I both as a player and a dungeon master. What I found is that it's so hard these days to find like a group of people that I know. Like I know that I could go online and find sort of like some random people to play with, but getting people that are sort of like-minded, friends with me that I know in real life, or at least, you know, online, and to do some kind of like gaming. Yeah, it's rough. I look like a DM. What does a DM look like? Would a Star Wars evil D&D campaign political strategic theme? I don't know. Right now, I have this entire universe campaign world that I'm sort of like building out in my head. Because if I can't run any like campaigns or do anything else, at least like doing world building is a lot of fun for me. So I'm actually wanting to, like, I've been working on figuring out something to do with maybe some kind of like async D&D with a community or somebody else. I'm running a ex coworker through a really like basic one shot that I've created just to see whether or not some async type stuff works at all. And I don't know. We're about to get into combat with that one, and it's interesting. So probably right now, I don't think I want to join in as a player. But thank you so much for the invite. Okay, let's take a look at this. I want a pub function. Let's just do this as run, and we don't have anything to return right now. And I want to return a result. Let's return an anyhow result. And in this specific case, I don't think we have anything to return. So it'll be like that. And we will take all of you, throw you in here. Okay, and you're going to yell at me because we don't have any of this stuff in here. So let's import you. Listener, incoming. Okay, what are you upset? Oh, you're upset because we're not returning. Okay, like that. Excellent. Stream that right all. Looks like we have a trait to import. We want import right probably. There we go. We do that. Excellent. Now, instead of this unwrap, what we want now to do is to convert this into a question mark to have it then send out. But what we can do is we can add context into it to say like, hey, what are we doing? So we are writing all response data and then question mark. And then you are context flushing right so that everything goes out. And question mark. Okay, so then everything here should be fine for right now. We're going to have to go back into main and call run. So let's match run, which of course you don't know what to do. So we have to use, what is even this thing called? CodeCrafters HTTP server, which meant to just Y that. You become lowercase. I wish I could do like the tilde trick for that, but I can't. Like lowercase the dash, please. Okay, so use CodeCrafters run. And so I can match run. We do that. We're going to have an okay. This has nothing inside of it, so we don't really care. And we are exiting at this point in time, so we can just do a print line and just say server exited. We don't really care at that point. And then error, however, is going to be more interesting. I probably want to do, let's see, do I want to do a couple things? I think I do. I think I want to say an ePrint line where we're going to have an error. Do I care about what exactly, like to put an error like this? Probably not. I might just want to do an ePrint line error. So print that out to standard error. And then we want to exit. So I can do a exit with code This type represents the status code. The current process can return to its parent under. So I think I could just exit code and we could just say one, whatever, because we don't, as long as it's not, as long as it's not a 0, that's an error as far as the shell is concerned. Okay, so I think that should be good. Let's go ahead and rerun this and make sure this works. And there's our curl. Okay, so everything is still good. Excellent. Let's see, what else do we have? Do I have a Discord? Yes, I do. And then Skimus, hello, how are you doing today? Thank you for the section. Oh, there was an ad there. Okay. Oh, sorry about that. Let's see. I don't know what I was talking about when you got the ad because I wasn't paying attention to the ad screen over there. So sorry about that. Let me know what it was and I can re-say it. Or did you get the, I also have, I think a Discord. Do we have that? Oh, it's not slash, it's bang. Does that open up? Yeah. So that's another way to get access to Discord. Nigel, you just learned something new about Helix. What did you learn? I was going really fast. I don't know what thing I went over. Okay. Oh, Tilda. Yeah, so Tilda with this thing, like where I can. Oh, I was doing search. And I was like, why is that so weird? Yeah, so I can make things upper and lowercase with the tilde. Something really fun is that's not only a Helix thing. If you're doing any kind of Vim like, so if you're on VI, Vim, NeoVim, probably any other the other Vims too, like AstroVim, and there's hundreds of flavors. That should all work by default too, unless of course you're working with something that has changed the default control scheme, which in that case, it's somewhere on your keyboard. Who knows where it is? Okay, so this is now our main. We are, this makes it pretty simple. We don't have anything to pass into it, which is great. In the library, we are no longer unwrapping, which is also nice. Now, I am setting up this response like this, and this is sort of like, I don't want to call this the header, but this is like maybe a prefix or protocol, perhaps. Now, everything is going to get this, right? And I wonder if I want to like create a function to hold something like this on, because we're going to want to write all and have response, but I'm going to want to sort of like put together into like this header, like the status code, the message, and then CRLF, and then headers, and then body at the very end. And I'm wondering if I'm going to want to do something like a create response function that sort of builds this up. I don't know. I'm going to put in a message here, like probably want to turn this into a create response function at some point. Now, once we have this response, then the rest of this should be fine, right? We're just going to write this. We're going to write this. We're going to make sure that it flushes and gets all sent out. And then this error. So this is interesting. Do I actually care about printing this error here or not? Because I don't know if I do. Now, this just prints it to standard out, which is not Great. And this is for me listening to incoming events. So the server should absolutely crash if this fails, which makes me think instead of matching stream like this, we should change this to be something more like, I could shadow, okay, we can shadow the stream. So stream equals stream question mark. So I could do something like that. That then takes this error and then just sends it on out through this result. There isn't a way for me. Wait, can I just do this here? No, I can't do that at this point as part of you. And I don't think I can put the question mark in here. That'd be weird. So yeah, I think I need to pull it out at this point in time. Although I don't want to unwrap it here. Yeah, because like, okay, so this is an iterator, and then each iteration, so we have multiple of them, is going to be a result. Okay. So that's let's get rid of our match and you, which means I don't need okay mute stream like this. Get rid of you. We just want to take this response stream. So we can question mark you there, and that's great. And then you need to be mutable. If you need to be mutable, wait. You don't need to be mutable? Oh, stream moved due to this method call. You could clone the value and consume it. So I could try clone. Oh, probably clone beforehand. I could okay this and get it out. Is it the result that I've lost? Okay, hold on. Let me try this. If I do that, now you need to be mutable. So that's what it was. Okay, so basically the result was attempting to clone over and over again, but I don't care about the result itself. So we're just going to shadow stream and extract out the result here. And then get access to that. Okay, great. Now we can use those to here when we write all and when we flush, and then we figure out our response. So it's a little bit easier to look at, a little bit less indented in, which is nice. Okay, so I think for right now, this is the only part where I'm very certain we're going to be refactoring this shortly, but I don't exactly know how I want to do that right now. So I'm going to go ahead and leave that. Let's go ahead and re-push this up. All right, so git commits. And this is refactored logic into live.rs. And it should still say that we're passed. Yes, excellent. Now we can mark the stage as complete. Extract URL path. In this stage, your server will extract the URL path from an HTTP request and respond with either a 200 or 404 depending on the path. HTTP request. An HTTP request is made up of 3 parts, each separated by a CRLF. So this is the request coming in, not the thing going back out. So we have the request line, 0 or more headers, each ending with the CRLF. So request line, so this would be the request line. Then we have headers, optional request body. Sorry, it looks like this is the full header. Then another header, and then body down here. Here's a breakdown of the request. Okay, so we have request line, we have a get, so HTTP method, we have all that stuff. That's great. The request target specifies the URL path for this request. In this example, the URL path is index.html. Note that each header ends in a CRLF, and the entire header section also ends in a CRLF. So we're going to need to do a little bit of parsing and looping here. So that's going to be fun. So first, the tester will send a GET request with a random string as the path. So we expect that to be a 404 response. Then the tester will send a GET request with the path /, and your server must respond to this request with a 200 response. Okay, that seems perfectly fine. You can ignore the headers for now. You'll learn about parsing headers in a later stage. In this stage, the request target is written as a URL path, but the request target actually has 4 possible formats. The URL path format is called the origin form, and it's the most commonly used format. The other formats are used for more niche scenarios, like sending a request through a proxy. For more information about HTTP requests, see their documentation. Excellent. Okay. So, first off, we should probably just see if we can get the entire request and see what that is and print that out. So when we get our stream here, let's see if I can just grab the request out. So let's do, we have a request equals stream. What? I thought I could scroll on these now. Oh, is that only help stuff? Now there's read to end. So I wonder if read would work. And these are snippets now. Okay, so peek. Okay, so I don't think we want a read timeout. My guess is that I could read the entire message into a string, which should be fine for this server, because I don't think we're going to run into a problem of everything running out of memory. Now, read vectored, like read, except that it reads into a slice of buffers. Data is copied to fill each buffer in order with a final buffer. I don't know how much of that I care about. And then read just pulls in some bytes. And then I have to just deal with that myself. Let's try read to string and just see if that works. So first off, you want the string. Okay, so then, oh, this is going to be the size. So I want to do something like mute, sorry, not mute. This is going to be a string new here. We're going to make you mutable. We put in a mutable reference to the request. we're going to context and just say reading stream question mark u. And then let's go ahead and debug the stream. Stream? No, the request. And see what we got. I suppose I should spell things correctly. That would probably help. Diablo, hello. How are you doing today? Cat? It's a good question. Okay, next ad starts in around 30 seconds or so, it looks like. So let's go ahead. During the ad break, I will go find Cat and bring him in. I guess in the meantime, let's go ahead and run this and see if we get anything printed out here except error. I see the error dot here. I don't see the squiggly lines. No semicolon. That would do it. Okay, there we go. So if I curl and we just go to just something like that, I don't see no debugs happened. So I don't think that worked the way we expected it to. All right. So we're gonna have to figure out how to actually read the bodies. Read a string is not what we needed at all. So I'll probably actually have to read into like documentation of TCP string or something like that. But that being said, I'm gonna go find Cat. Omnifitus, hello. How are you doing today? Okay, well the ads are starting there we go. Ads just started. I will be right back with Cat. All right, I'm back. We have Cat. He's not in his like super like hanging out phase. His name is Zilby for those of you who are new here. He's he's a little bit over 3 years old. He's been hanging around with us. We had him on stream, so he's been with us since like he was around, we think, 10 weeks old. He's a rescue, so we're not completely sure. But he's a pretty standard American mid fur cat. So he's not a short hair, but he's a standard American cat. He has one brain cell because he is orange. Exactly. Are you stand over here? You want to look at the mic? No? I can't tell what he's looking at. Like we have some blinking lights, we have just like the microphone up here. He's not purring, so he's He seems like engaged. Okay, you wanna look outside? I'll open a window for you. You have to get off me. Okay. Okay. You just hang out here. No? You wanna hang out on me? Oh, I've not set up the cat cam. Okay. Well, that's a problem. It's a problem that Zilby solved by just jumping down so the cat cam won't be able to see him anyways. He got offended when hearing he only has one brain cell. That's probably true. He's gonna hang out on the floor next to me. He's been doing this when I'm not streaming recently, hanging out on the floor down here as opposed to like up high where he can look out windows, which is strange because I always thought that he loves looking out windows. But okay, what did I miss? Let's see. Read to string doesn't work because read to end string doesn't return until the stream closes on the other end. It might work if you control C and curl before control C in the server. Oh, okay. That explains that. Okay. So, okay. So, read a string won't work because it needs it to actually end and finish writing essentially for us. But we're reading just sort of like this ongoing thing coming in. So instead, we need some other read. Now we have just read, pull some bytes in, but we need to know how many bytes, right? And do we know how many bytes? I don't think so, right? Now there's read vectored. Oh, actually, no, wait, this doesn't tell me how many reads. It's just gonna pull this in. Okay, so this maybe we can just do this. Also, Chantilly, hello. How are you doing today? So if I just read, let's try you. So if I read, we read into the request. Now, you won't be able to do this. We're gonna make you be just a good old array. And now if I print you, that's not really gonna look that great. Like it will work, but I would probably want to turn this into a string or something like that. And let's see, what can I do with a reference? What you got today? Oh, right, because Labor Day. I keep on forgetting, like I even mentioned it at the beginning of the stream, but I already forgotten that today is a holiday. Okay, so request dot, what can we do? So I don't want to bytes. Oh, wait, it's not, it wouldn't be, I can do like a string from bytes, right? So can I do like a stream? Oh, can I do stream? Oh, sorry. Request to stir. There's like as the pointer. I don't think that's what I want. None of that. Can I do a string from UTF-8? That's a vector of U8. Isn't there like a from bytes or something like that? That's a zero size array. It'll only read zero number of bytes. Oh, you're right. That would, yeah. How do I know? Okay, so how do I know how big this is going to be? Or can I hand it? Okay, so string from UTF-8. Okay, so that'll work for that. But you're right, Skimmas, that's going to be a problem here, is we need to know how much of this stuff is coming in, which includes the body, which is unknown, right? Although I suppose if we think about this, we know that we're going to have this, right? Oh, this is unknown because that could be a different size. Generally with read, you handle it like OU8, 512 or something, and read returns the number of bytes read. Just give it something really large. Probably just want to keep calling read until the returned read size is 0. Oh, so I could basically just create a bunch of these, concatenate it together with something else, and just read it over and over again until we reach the end of it, which does sound appropriate, and that does sound like an appropriate first function for us to do. I'm going to do it down here as opposed to creating another file. So if we have something like a function like read stream, let's say. So we're going to take in the TCP stream. So we can take ownership of it here because can we? Do I need to take ownership of this here? Or can I get away with maybe a reference to it? Let's try a reference first and see what happens. And we're going to return a vector of probably U8. So bytes, essentially. That is the same problem as read to end string, though, because the curl doesn't close the stream until curl considers the request finished. Okay, so wait. So I can't read until the return size is 0 because the return size will never be 0 because it's a two-way open connection, essentially. Or, no, it's a one-way open connection from client to server. And they could be streaming stuff to me, and so the size is never going to be 0. Is that what you're saying, Japfo? Because that would kind of suck. Now we know if we're going to get I could just read this in chunks and just sort of like randomly choose how many chunks to get it. And that I think that's what you were talking about with the 512. So just get it in chunks of 512. Yeah, the size will be 0 when curl closes its end of the connection. But of course, we need to respond before they close. That would be helpful, right? Okay, so if I want to, let's just do the 512, the chunk size. So if I do like let mute, I'll just call this chunks for right now. We'll call this request chunks. I think what I want to do is actually just we're going to start with a request, and that's going to be a new vec. We're going to return the request at the very end. We are going to then have to do an infinite loop because we don't know when this is done until we hit both CRLFs. That's what we have to look for, isn't it? So we do an infinite loop, and we're going to have to now get a new chunk. So let mute chunk is going to be equal to an array of, now you had OU8, right? What's the OU8? Yeah, you had OU8. What's the difference between what's OU8 versus just U8? Because I could just do that too. U8, then we'll do 512. Oh, it's a 0. That is a font problem. I thought maybe like an O was like a special thing. It was like, no, just fill it with zeros that are U8s. I can do that too to like make it a little bit more obvious. Okay, makes sense. Got it. Hey, thank you, Isitsu, for that. Okay, so we create a chunk here. Is there a reason I decided to put a bang there? I don't think so. It's not a macro. Okay, so we have our chunk. I want to now read this chunk in from the stream. So we're going to do stream dot. Now, I can't read to end for the same reason I can't read to string, right? Because there's no end for this. So I want to read, pull some bytes from the source into the specified buffer, returning how many bytes were read. So I want chunk. I probably need to know how many were read for this so that how many read. We will context this. The context will be, and also you get banned. Okay, so context is going to be reading chunk, reading request chunk. We'll question mark you. Now, this means that you need to be, let's see, you're a vec. I want you to be a result that we return a vec u8 in. That's great, which means you need to be an okay with the request. Okay, that's great. How many read? Okay, so, okay, stream. Cannot mutate in variable. Okay, so you can't just be that. You need mutable reference. How many read? Okay, so we're not using that yet. But now we have a chunk, theoretically, and we do this infinitely. And so when how many read is 0, even though it's not closed, there's nothing more for me to read, theoretically, right? Like that's the theory here. So if how many read is equal to 0, then I want to break. Yeah, I want to break out of the loop. And then we're going to take in the stream read. So we're going to take this chunk here, and then I want to append this. So request append chunk, which is a vector. The other has to be a self. Do I have to turn this into a vector? Wait, there's a concat too, right? A concat takes T. Okay, so a concat, and we hand it chunk. This method takes 0 arguments, but oh no, that's not good. Also, you also get banned. Yeah, it's just going to block on reading, which is not going to be fun. So this one is like, this is not sure if correct. That's one thing there. Concat. Trait bound. U8 concat is not satisfied. SS concat. So wait. I can't concat from the other thing. Oh, extend from. Oh, that's what it was. I think we've used that before. Request. Extend from slice. Chunk. There we go. Expected a reference. It's fine. We can do that. There we go. Perfect. Thank you, Japo. Okay, so now this gives us some. It gives us a test here because we don't know if this is going to work, right? There's a couple different things that like may or may not work about this. For example, we're pretty sure the chunks are going to work. How many red may never become 0, so we may never exit this loop. And yeah, the fun things about that. Rishi, hello. How are you doing today? Now, what we can do is we take so we have our stream like that. I want to take our request and we're just going to call read stream and pass in a mutable reference to stream. We're going to context this and just say reading stream like that. Now this gives us a vec of U8, and I wonder if I can turn this safely into a string. Let's find out. Do you go for a buff reader and read line until you have all you want? Ooh, that's another good suggestion. So we can do possible ideas. So buff reader and read line. That might work. We should let's add that. We'll try that out next. I want to see what happens here. Now if I take this request, we're gonna do a string from UTF-8 and to the request. Let's just question mark you. I don't need a context for you because we're just doing this as a test. Anshul, hello. How are you doing today? You did this challenge in Rust last month. Nice. How was it? Okay, you're running. Let's go ahead and curl this. And I saw a lack of messages popping out behind me. So that means that none of this worked. Okay, so what we're going to need to do is throw in some debugs or some print lines to sort of like see where things are happening. So for example, if I do a print line here, we'll just say like starting to listen. That's an option, you guess, but readline would also block if you don't get what you expect. The real solution is using non-blocking IO, but I think it's beyond this exercise. A hack that could bypass this all would be using TCP stream set read timeout, so you get an error on timeout. Oh, we could, yeah, we actually have access to that. So we could set the timeout so you get an error on timeout. Same issue that I'm having, the stream was not ending. I think you ended up using a constant size buffer. Oh, what Japfo said. Okay. So you set the timeout, but then also a constant size buffer. So I am setting up to use a 512 size buffer here, but then I do this over and over again. But yeah, and I think what we need to do is in here parse through until we see the double CRLFs. Rishi, you're doing great work. Keep it up. Thank you very much. But more importantly, we didn't get any. I didn't get this coming out. So something happened. I am blocking on something and not getting to where I want to get to. So my favorite way of debugging this is the good old print lines everywhere method. One thing I can do, let's switch over to a cargo watch run here. Do I want to run? I don't think I want to run. I think I want to do a cargo watch. I think it's C for command, and then that is your program. Found argument watch. What did I do? Cargo watch, which isn't expected or isn't valid in this context. That's interesting. Where was that error from? What's happening in your program? Set environment variables. You cd into, you build release, and then you exec it. Okay. Changing this script will not affect how CodeCrafters runs your program. Right, because I could totally just like cheat in here. So they don't actually use my script for real. I wonder if I just did, okay, cd into the appropriate directory. If I do a cargo watch, I think it was -x run. Now you're using a -- release, which I'm not sure I necessarily need. And then exec this with, I don't know what that does. Oh, this will this just does a build on it. Okay, so I build it and then we execute and run it. I bet that we could just do a over here. I can probably get away with a cargo watch X run with this. That runs that. And now I can curl these. And I should be able to see whenever I make any changes here. Yeah, then it rebuilds. So we have starting to listen. There it is. Okay, starting to listen. That's great. So we get you, and then I want to maybe receiving incoming message. There, receiving incoming message. Excellent. Okay, so I extract out there. I get the request. Now, so if I do something like got request, receiving incoming poorly spelled message. But we never get this request. So now we know that it's in read stream here. This loop, my guess is never exits. That's my guess here. And so if I do something like print line about to read stream, let's print line looping while getting chunks. And then down here, we'll do a print line got all the chunks. Okay, so if we do that, my guess, 2 looping while getting chunks. Excellent. Now, let's see how many we actually read. Let's try a debug of, let's just do a print line. Print line, we read, how many read chunks? Okay. Starting to listen, receiving incoming message, about to read stream, looping while getting chunks. We read 88 chunks. Looping while getting chunks because that was less than 512. But if we think about this, if we read less than our buffer, then that means we have read to the end. So if this number is less than that, we are done and we can exit out of the loop and we're fine. Let's see. I cannot read your user name. But hello, how are you doing today? Your thumbnail is very simple. You like it? Thank you for that. I've been experimenting with like actually putting my face on thumbnails, making the face bigger, but also keeping it nice and simple. So hopefully I'm working with that. What do I mean by HTTP server? So HTTP servers are like the backbone of most sort of web JSON or other types of servers that you might use. So if you've ever created like a Node.js server using Express, or you've created a server with like PHP Laravel or Python Django, it's basically one of those, except very, very, very simple. We are not creating a framework around it. So also open source. Hello, how are you? This is not an Axum web app. This is we're doing a challenge to create an HTTP server which would be closer to Tower, which Axum uses behind the scenes. Does that make sense? Excelion, I have, my brightness is not high enough to read the color that Twitch decided your username would be in. Hello, how are you doing today? Am I planning for HP 1.0 or 1.1? 1.1 it looks like, because they're having me return that as part of the header, which we can see up here. So 1.1. All right, so let's have a buffer size, and I'm going to set this to be extremely small right now. So we saw that this was 88 chunks, which if I move out of the way, you can see that a little bit better. Now, if I do this, let's see. I don't want this to be even. Let's do this 40. So here's our size, 40. And I want to use the buffer size here like that. Attempt to use a non-constant value in a constant. Can I put a constant in a function? I feel like this would be the beginning. Okay, fine. Go down. This is potentially the reason to put this into a different file. But okay, so if I put this as like 40 here for right now, and 88, right? 88 is going to be 1, 2, and then on the third one we exit, right? So I should be able to see we read 40, 48 chunks. I'm going to keep this as how many we read to keep it as blocking. but that's the goal. Is I want this to see this as 4048. So if we run this, and that's exactly what we see here. We have 4048. Multiple write calls on a client and could end up with separate successful reads on the server with less than 512 bytes read. It probably works in this case, though. In practice, some buffering happens on the OS level and both ends, and probably in routers in between. Like, imagine if the client calls write once for each header. Yes, and actually this is something that happens in, I don't know about like some of the other frameworks I've used, but like, for example, in programs I've worked with in Node.js and Express, it is absolutely possible to do something like, hey, we're going to write out, and then also, hey, we're going to now set a header. And you do 2 writes then, and weird things might happen, which is always interesting. Annoying. HTTP 1.0, you could use content length. You can use a buff reader, and lines take while is empty to get the initial request line and then do it again for the headers. But we're going to hit the same issue for body. Yeah. So also, can I run this? I guess I am running it right now down here behind me. So that's the logs for me, like running the actual program. So it's constantly running. All right. So now that I know that's working, what we could do is I can set this back to 512 or something like that. And really what I want this to be is if how many read is less than, oh wait, I can put const anywhere? Oh, that changes things. So can I do const buffer size? So let's do 512. Buffer size like that. And if you're less than or equal to buffer size, then we break. Okay. So if I do that, are you a U size? Can I make you just a U8? An E8? A U8. What do you need to be? You need to be U size. Okay, so there we go. You're working now. So now I should get all the chunks and return that. And then we're going to try to print everything out that we got. So let's do this. Okay, so we got request get. Okay, so here's our request. It's a get, and then that's our path that we handed it. I'll full screen this so you can look at all this and its beauty here. So get the path HTTP 1.1. CRLF, we get host, so there's a header, we get the user agent header, we get an accept header, and then CRLF, and then an empty by, these are headers, and then we get CRLF, and then I think an empty body, and then CRLF. I think that's what that is. And then all the zeros are just because we went with a 512 size chunk, and these are all the unused ones because we initialize them with zeros. That's what's going on there. Okay, so I mean it makes sense. We actually got this now. Oh, you know what? I don't have the auto change theme for some reason. The thing broke, and I need to fix it sometime. But let me know what theme you want to change it to, and I will change it to that theme. We haven't had a change theme in a couple streams though. Everblush. Actually, I can I do this manually by hand? I don't remember if I ever set that up. Okay, I'll just do it here. Theme Everblush. Ooh. It's a very subtle change, but it looks nice. Wouldn't this break on a body larger than 512? It shouldn't, but there's a way for us to test that, right? Because I can just come to my chunk size. And let's just set this to be something absurdly small, like 8. So if our chunk size is 8 now, it should be reading 8 little bits at a time and then sending that in. And we know that we have an 88 size body. So if I write you, I feel like this didn't, why am I down there? Okay, I feel like it went way below my buffer size, which is fun. Okay, so if I find stripe, I want to do a curl. I did a less than or break if it's less than or equal to, which you're right. That is wrong. It needs to be less than. Okay. Now we get all these. Oh, because it's exactly 8, it doesn't work. If I make that 9, then that works. Okay. That's fun. That was a fun one. So now Acceleram, it shouldn't break on anything larger than 512. But I think it was going to break on it. Let's see. You don't know about Rust language, what field cover? Rust covers, it's a generic language. So by generic language, that's similar to C, C++, Python, Node.js, Java. Basically, it just means that it is a language that can do pretty much anything that you want. It's not like hyper focused on one specific domain. It used to be billed as a systems language, but the Rust team no longer really focuses on that messaging anymore, mostly because they just want it to be more inclusive to other developers. But it can be very fast. Like it tries to run as fast as possible and also have a lot of modern high-level programming sort of helpers set up for it. Am I a Mac user? Yes. So you can see I am running Mac right now. In our region, Mac is so expensive. We are using cracked Windows or Linux most. Yeah, I totally get that. Like especially outside the United States, like it can be really tough to get Macs, or even just some of the other computers, right? Because like there's a lot of pre-built computers these days that have gotten themselves up to the same price point that Mac has. Do I know PHP? Yes, I do know PHP. And at my last job that I worked at, or I guess the job I still have a contract with that I'm working at, we do have one PHP project. It is a PHP 7 dot something, and we're running Laravel and Yi in the same project, which is, don't think about it too much. It'll break your brain. Don't, just try not to. But yeah, it's fun. Let's see. Yeah, now we'll break on a total multiple size of 9. Yes, that's true. It changing the buffer size won't really fix it, but now I can, every time I run into a problem with it, I could now just change the buffer size to something else, and then it will work. Okay, so I probably should do extend from slice chunk how many red instead, so you don't push all those zeros to the request vec. Oh, yeah, that's a good point. I probably should do something like that. And then the other thing would be the buffer size, figuring out like how many red read up to it. Unless you coincidentally change the size to another factor of the total size. Yeah, which is possible. We can do like, okay, we're going to do 9. Let's do 3. That'll work, right? I mean, 18 might work, but yeah, I could totally see like weird problems like that. Now I can't, it would be hilarious to do something like, hey, we're going to do 18.5. Okay, so I put in an illegal number there. I wrote in 18.5, and is this the theme? Did the theme make my text disappear? As soon as I put the dot, it disappears. That's weird. I think that must be the theme, right? Okay, so if I do that, and then the other thing was extend from slice, and then we can do, what was it? It was dot, how many red, to not put any zeros. And so now if I put in something like we want 1024 size, and we print out what we get, we should not get all of the zeros. Perfect. You are not allowed to use illegal numbers. Yeah, that's true. If you can't see the errors, do they really exist? See, this is perfect, Nigel. We don't, if we can't see the errors, they don't exist, and therefore it's great, right? Like the second that you're like, hey, I want to use this as like a 0 dot, oh wait, okay, undo. Just don't type too fast. Okay, so this is good to begin with. This might be a good comment to put in here, which is this buffer size could cause problems if it happens to be exactly what we end on. Simply cease to write any syntax errors. Or as another instructor that I worked with in the past has said before, just code it right. Never run cargo tests, never? I mean, I guess. But wait, no, that doesn't make it all disappear. Just writing it bad makes it disappear. Canva can make white YouTube thumbnails. Yeah, that's what I've been using. I've been playing around with Canva a lot recently. Okay, so we've got all you're working, everything's great, and now we see you. Okay, so we have get to all of the stuff behind me. You only do logical errors anyways. Yeah, like we don't want hard errors. We want logical errors. The errors that that Rust won't protect us from. Okay, so now this gets the raw body, the raw request, right? It's like this gets the full request. Now, if I want to break this out, I want to parse this into its like parts, right? So let's do now that we've got this, let's create a function that we can call parse. I'll call this like parse raw request. We will take in that vector and we can probably own it, right? Because we're just going to convert it into something better. So let's do the request, which is going to be a vector of U8 is perfectly fine here, I think. So we don't have to like convert it into strings and have other weird stuff happen. And we are going to return, I don't know if we need to return a result. We're going to return something. So I'm going to put that for there for right now. My guess is we're going to return a struct, which we're going to call a request. So if I have like a struct request, we know, let's see, this first part, like get, for example, we know that that's going to be a, that's going to be the verb. Should we call it? No, that's not the verb. Is it a verb? Method? I think it's the method. So we have the method and maybe we have an enum. Method, but in a cargo.toml. Okay, I only have anyhow bytes and this error. There is an HTTP. There is definitely an HTTP crate that I could pull in that gives us all the methods. And then I don't have to write my own, but I also don't know if we need anything more of it. So if we just stick as long as we can before we start like pulling other stuff in, and we just say, hey, we're just going to have a get. And I don't really care about this, right? And so if we say that I want this to derive debug, so I can debug this out. Method is going to be the method. You're also going to derive that. Okay. So let's now figure out how we can create this method. Sorry, this request. So given this, we know that I want to go until I have a space. So I want to just read through this until I get a space, and then that's what I do. We can make websites, but it is hard to collect users, so we give up when users base too low. Infinity Free is offering free hosting and free domain with HTTPS. I mean, these days you should be able to find free hosting for just like simple web apps in a lot of different places. Like if you're a developer, you probably have heard like many different places to go. Like Vercel is one. If you know what you're doing, you can use Cloudflare. CloudFront with AWS and S3 is like practically free. It's like pennies per month at most for that. So there's a lot of there are a lot of very extremely cheap and free options out there. Ray March, hello. How are you doing today? Used Chomsky for your last parser. Found it quite cool. I'm gonna see if I can do it without pulling in a library because I think that's what the crux of the challenge really is trying to get us to do, is like actually just do this on our own. Will CodeCrafters try to detect whether or not you're using HTTP crate in a project? You're supposed to create your own HTTP server. Oh, that's a good question. I don't know if they will detect that. That would be hilarious though if we just like, it's like, hey, tower, or just like spun up an Axum server and it's like, hey, okay, it works. but yeah, what would be the point of that? It's this thing like CodeCrafters isn't cheap, right? Like CodeCrafters is one of those things where we're paying for it. Although full, disclosure for those of you who have come in since the beginning, I did not pay for it. I'm partnered with them. But if you pay for it and then you cheat on it, who are you really cheating? They're not really cheated there. I think it's the person trying to learn is the cheated one, right? Okay, so parse from the raw request. Okay, so I want to read through this and get to the space, but I want to keep everything out here. Yeah, congrats, you fooled yourself. Exactly, yes. I've had when I was teaching. Okay, so side thing. When I was teaching at a in classes, so at the code school, this was a thing that commonly came up all over again, like all the time, and we had several people from Teach from America who were training us to be excellent teachers, and we asked this question multiple times, and the person who was sort of like in charge of the team, he basically said, look, these are adults that we're working with, and at some point in time we have to just accept that the adults are going to be there. We can't like force everybody to learn. We can't just assume that people are coming in and paying a lot of money just to ruin their own education. Like at some point we just have to trust them, and if they cheat, that they cheat. They're not going to get anything good out of it. So that is something to consider and be aware of. All right, so parse raw request. Let's see. We should probably do this one character at a time because we have an unknown. So I want to, okay, so when doing standard parsing type stuff, I probably want like a let mute, just like the character. So like the next char that we're getting. And should this be an option or should it be just a null? Like I could say this is a none. Or we can loop through this. So if I just I don't want to name it char, so maybe do it as next char in request dot. Can I get chars? I guess that's U8, right? So next char may not actually be completely correct because I mean it's kind of a character, but it may not be an actual character. So that is something. I don't want to call it next though. Oh, next byte. So we could do next byte, might be better. All right, I want to check to see if next byte is a space. So if I do something like const space, and I want you to be a U8, is equal to space can I turn this into a there's something like B, that's what it was. Yeah, there we go. Okay, so now I can say if the next byte is equal to space, then we're done, right? So the first one here is going to be getting the whatever this is called, like the current method. So if I do let mute method, I could do this as like a string new. But I think this makes more sense to do this as just a vec. Like that. Londo, hello. How are you doing today? Londo, thank you so much for the subscription. Thank you, thank you, thank you. 29 months too. That's so many. Let's see. I am. Okay, you're chatting with each other. Perfect. Okay, so if the next byte is the space, then we know that we are. Can you see that? Kind of. Like, I go this way. We're right there. So that means that I now have the method, but if you're not a space next, I want to push you in here. So I want to say else next byte, sorry, method, and we're going to push the next byte in. Now, if we get to this next byte space, then what do we want to do? I want to sort of like, we want to end, right? I want to end the for loop, at least for right now, because like in reality, I don't want to end the for loop. I want to go through and get everything here. And I'm thinking that maybe we're going to need some kind of state machine for this, which sounds like an enum. Because if I do something like another enum, this is definitely going to make its way into its own file, because this is going to become, all of this logic together is going to become its own thing. So this is going to be the request parse state. Okay. There, I did actually, okay. I wasn't sure if I was copying that into paste buffer or not. Okay, so I have request parse state, and I want to throw this into, okay, what are we gonna start? We're gonna start with method, like that, and we will add this in here, and then we start with, we should have a default. And we'll set method as our default. Okay, so request part state. So let our state equals request part state default. We get you. So if next byte, I want to go to next to go on to the next state, whatever that's going to be. So move to the next state. But if next byte equals space, that's not how they all end. So that's going to be something else like this too. Caterpiggle, hello. How are you doing today? What's the benefit of Rust over other languages? I think it's sort of going to depend upon which languages we're talking about. Benefit of Rust over something like JavaScript or Python would be the really strongly typed system that you get access to. If we're talking about something like C or C++, there's a lot of, there's an entire ecosystem for using crate and grabbing packages from other users really easily. And if it's something like TypeScript, then you get the benefit of a compiled language that's not necessarily like focused on web, that has like even stronger type system, that has all the same benefits of that, but can run faster. So things like that. Fearless concurrency, yeah, like the borrow checker is a huge thing. So like the memory safety stuff, if you're working in a domain that needs memory safety and you're working in something that might be considered low level, so that memory safety is actually like going to hit you with the language you would otherwise choose. Like, for example, if you're going to ever work with something like JavaScript or Python, you generally don't need to worry too much about memory safety. Concurrency, yes, you do need to worry about that, but memory safety, probably not so much. C or C++, yes, then we're talking about memory safety stuff here. But again, only if you're using stuff where you're needing to, like, you know, do fun stuff with memory, which is most real applications. And then Rust can help there. Is it always the best choice? No, there's other memory safe languages too. There's memory safe features in some of the other languages as well. Like even C++, from what I understand, I have not used it, has quite a few memory safe features that they've added in over the years since Rust has come out. The question is, are you going to use it or not? Rust, by default, basically says, no, you are going to use this or we're going to not compile. And if you want that as part of your language, then yes, Rust is an excellent choice. C++ is nowhere close. Okay. It's hard to tell where things are because I don't have any C++ people to like talk to about this. And online, it's really uncertain what are the actual features that are there, and of just people talking about it, because people on both sides of like Rust and C++ and C defend the language sometimes a little bit too much, and with facts that may or may not be true. Yeah, people can get very heated about this. Absolutely. Now, in the end, the only thing that's really important, right, is delivered software that runs and doesn't piss off its users. And so if Rust helps you do that better than any other language, then Rust is the best choice. If you can do that with another language, then that other language can be a really good choice too. So generally speaking, Rust is up there with a really good choice, not always the best choice. C++ has made some unfortunate decisions that make it quite hard to retrofit safety features. I guess like another thing to sort of consider is that C++ is old. C++ has been around since the time in which we all, by we being humans who invented the internet and like all the sort of like infrastructure that we're running right now, assumed that we would never need security, like passwords on anything, because why would anybody hack stuff? So consider that. It's like, before we like blame the language for like not considering this, they did come out at a time when that wasn't like, we weren't even like imagining to create software of such complexity as we have now. You cannot write safe C or C++, so it doesn't matter if you delivered it or not, you failed. The thing is that, though, I believe that isn't exactly correct, though, because you can technically write safe C or C++, right? Like, you can technically write it. I think the argument for something like Rust is that you want a strong single source of truth, so that would be the Rust compiler and the borrow checker, that is heavily checked by the community to make sure that it is actually correct, that is then going to ensure that you're following safety as much as possible, right? Whereas with C or C++, every time you write something, every library that you pull in and use, it is got to be checked by the developer or the community individually themselves. You can't trust some other library that they're writing it in the same format and way that you wrote it yourself. There are plenty of static analysis tools and sanitizers for C and C++, kind of, that would give you the same safety checks as Rust. The problem is that the developers need to use those tools And many are vehemently opposed to the idea, even without a valid reason. And we're actually seeing that a lot right now with the big fight that's going on in the Linux kernel community. Is a lot of it is less about, Rust is like not supported or bad, and more of it's different than what I've taught myself, and that's not great. And I can understand arguments for it doesn't work the way we want it to right now. Those are perfectly fine and valid arguments. It's different, or I refuse to use those tools or something else, that's not necessarily a valid argument unless you can pull in something else that like actually is but we can't do it without it. Yeah, I have seen the NASA guides on it. It's been forever though. I forgot those. You do mandate them in your company, but it certainly was a culture shift. Yeah. In the end, most of these things are culture shifts. It's all about culture. But okay, let's continue on. I wanna every time there's always the possibility that we end up just like turning it into a let's chat about Rust stream, which is good and that's nice, but I also do want to work on this. So all right, continue on. If next, so this entire thing is questionable because like if next byte equals space is not always what it's going to be, right? Because sometimes it's going to be something else. Like last time, I should copy paste this in. Okay, so this is parse the raw HTTP request that we got from the client. Looks like this is one line, right? So I could do that. So it looks like that. Can you even read that? This is really light and dark for me. Although I have like windows and lights like on the other side of me, so that does make it a little bit harder for me to see my own screen, which is fun. Okay, so I guess my eyes are getting used to it now. I can see a little bit better. So basically we get to here, and that's great. But these the CRLFs are going to be the next thing that we need to worry about. So it's not always a space. Like for example, we do a space here, that's going to, well, mess things up. So I probably want to do something like, instead of parse raw request, or parse raw, maybe parse raw request has another function in here, which is going to be parse method from request. And then we take in that request. Let's see. If I take in the request, I probably want to skip a bunch of other things. Oh, random. Wait, can I do a random anymore? Oh, you don't let me choose a random. Hold on. Okay, so I can just close my eyes. Congratulations, Diablo. You chose a blinding theme. I just held tab and flashed the screen. That wasn't that great. Sorry about that, everybody. I probably should turn off the screen next time I do that. Okay, so and we can see the comments better now. That's a good thing, right? Okay, so I probably want to take you all out. So you get the space there. I want the method here like this, and we do a for loop like that. And then we're probably going to match on the state. And so we want the request parse state method. And so if we're here, blinding too, you use flat white. Oh, so you're already used to this. Okay, and then we're gonna call parse from method. So parse method. Oh, but then what I want to do is something like have a request. I probably want this to be a request builder too. So like we have a struct. No. Yes? Maybe. I mean, there's a bunch of different things I can do about this. Let's, if I do something like let mu, method. Equals, method is now going to be equal to parse method from request. Like that. Okay. You're upset because variable doesn't need to be mutable. Oh, because I assign it later. Yeah. That's how that works. Cannot find value request right. So you need to take in request here. I don't need to be a full vector. You can be a reference, a slice array of U8, which is great. Function takes one argument, so we give you a slice of request. Can't compare. Oh, because it doesn't have partial equal is not for that. So I want either a reference to this or I want to deref you, which can I deref you here? I can't deref you there. Oh, wait, I can do something like this, right? I guess I can deref you at that point. Yeah, that makes sense there. And then warnings. Okay. Cat or Pickle, you program in all black. Even the text is black. No comments. For oh, it's there. Okay, hold on. I knew it was somewhere. That one. Okay, perfect. Thank you for that, Skimmus. Okay, so we get that. Now what I probably want to do here is just say if you're not equal to space, then go ahead and do this. Otherwise, we're done. So we break. That gives us the vector of these. I want to now return an actual full string. No, I want to turn the method that we're actually getting, right? So We're going to turn that method. So we want to, I mean, it's not fast, but I don't really care if this server is super fast. So I kind of want to just turn this into a string and then deal with that. That's one way to do it. The other way is that I actually just take these, like take the get to bytes and then compare that, which would also work. But if I do something silly, like string, can I do stir from? Can I do stir method? I can't do like as stir here. I can only do this with a string, right? Impl from stir from method. It would be from vec of u8 for method, right? So I could do impl. Wait, does bytes do from stir? I don't think I can do that, right? Yeah. Okay, so impl from, we're gonna do a vec of u8. Okay, so impl from vec of u8 for method. Okay, so we get our value of u8. I don't need to convert this into a string, but I'm going to. So let's do our the string, like the raw method. Oh, there is a UTF-8 chunks, but what is that? What would that do for us? Okay, so rep from UTF-8 value. I could do a try from on this instead. That might be better. Is it try from? I think it's try from like that. What? No, stop. Don't try to update. Do that tonight. Oh, type error equals what? Can I do an anyhow error? Okay, anyhow error. Okay, now we have our try from value that, okay, does all that fun stuff. Yay. We get u value. So now I want to what do I want to do? I want to let our, so like the method string, it's going to be a string from UTF-8. We pass in the value. I can I actually context this? I don't think I can. I think I can. Actually, you know what? I think I can do that. We are converting bytes to method string. And I can't. Can I question mark this? I think I can. It'll consume the vector, but I'm pretty sure that that's okay with vector right now. Yeah, we'll just take ownership of this vector. All right. So I take we now have this method string, and now we're going to match on a method string as stir, because why not? And so we're going to have if this, method string. This should always be uppercase, but because I'm very paranoid, I'm going to uppercase it anyways. And we're going to say, okay, if it's a get, then we're going to return a self get. Like that. So we match from you, and then I want to return this, right? So this becomes an okay. Like that. Mismatch types. For loop evaluates type nothing. Oh, because I'm returning. Parse method from request is going to return a method. Oh, because I haven't returned anything yet. Okay, don't yell at me. And then if you are an unknown, I want to anyhow. Oh, can I do this? Will this work? This let's do an error saying unknown method. Oh, I have to turn an error, don't I? So this is a shoot. Oh, can I bail? Oh yeah, that totally works. Okay, then I just have warnings. Okay, perfect. So now we can. So a method, I get this. I now want to use a method from try from method. And you are an anyhow error, so I think I want this to be just a result. Result with a method in it, like that. And then I think you're okay. Yeah. So now that gives us a method from the request. And so at this point in time, I get the method, and now we have the method in here. So context is getting HTTP method from request question mark u, and now we have the method. So all of that for this. Excellent. Okay. All right. What's next? We haven't actually done anything of any value yet. I guess we have this method. That's great. We need the what I probably want to do is actually print this out to make sure it's doing what we expect it to do. So down here in our run, we have read stream. Now I have this. Parse the raw request. You're yelling at me because you're, should return result or option to accept question mark. Yeah, you should. Now, parse the raw request. I want you to return not that, but the request. So down here, we're gonna have to do an okay request method. Okay, so now we have you. You don't need to be mutable yet, so I'll just go ahead and we'll just get rid of all the warnings. Okay, so parsed raw request is never used. So we need to use you in here, read stream. So we get the stream. So this gets us the full request. Actually, not here. So that gives us all the chunks. Okay, so here's the request. Read stream. We get that. Got the request. So then I probably want, so this is maybe the raw request. And then I want this to be the request is going to be parse raw request, hand it the raw request. Okay, that gives us the full request. Instead of trying to turn that into a string, we then just debug this. And there we go. Kubilium, am I running a server or a novel? It looks fantastic. Yes. Yeah, we'll just go with yes. Okay, so behind me, I should be able to see the request come out. So let's go ahead and do this. So if I run you, we get to see our method get. Excellent. Okay, so we wrote a whole bunch of code there and it worked, which is amazing. Okay, so that's of course not everything that we need right now. We want, because what we really need to do is find out about this parse. This path. That's what we need next, is path. Change Helix theme, anything dark. Thank you very much for that. I usually use Advaita Dark, so I'm going to go back to my default. Thank you for that, Ray March. All right. So, I want to parse the raw request. We get that request. Parse method from request. We try that. Struct request. Okay, so as part of the request, the next thing would be the path. And I'll probably just make this a full string, which will be fine. There's probably other things, like I might want, like if I had URL in here, I would put that in there, but we don't. So I'm just going to put path as a string and we're going to deal with that later. All right, so errors. So we now need a okay, so I need a path like this, which means when we're parsing the state, I need to grab, okay, so parse raw request. Okay, parse raw request comes after this. Where am I going to update my state so I know which the next thing I'm getting out of it? Because what do I need to care about that? I think I do. Or we can use a cursor. Because if I use a cursor, then I can pass that into the parse method from the request, and then I know where we're starting from the next time. Because now it's more of, okay, I want to parse this out of it. I've already parsed this. Why should I need to like skip the first bits again, I should probably use a cursor, shouldn't we? Now, can I easily do that? So we have this request here. So can I do like cursor? That's gonna have to be mutable. Are all the cursors in libraries, or is there like a default one in a standard library? Creates an adapter which implements the read trait for self. Okay, it's a struct probably in standard IO. So there's this reader. So if I do a reader like that, and then I do reader dot pull some bytes from the source into the specified buffer, returning how many bytes were read. Mutable self. Does this mean that it's now at a new reader? I think it does, right? Read all bytes into buffer until the delimiter byte or end of file is reached. Probably not, right? I don't want to split. Okay, so if I did a reader, you're going to need to be mutable. Okay, you're going to be so upset at me. But okay, don't worry about it. So now if we say a mute reader of U8, right? Is it the readers of U8? No, the reader is a slice. Oh, that's a little bit. It's maybe a little bit odd, but okay. Okay, so we have you. I can't get. Yeah, I can't get the next one. So it's going to be the request. I don't want to transform it into bytes. Pull some bytes from the source into the specified buffer, returning how many bytes were read. Read until would be amazing. Read all bytes. Okay, so delimiter. Is that... Where's my delimiter go? U8. Is that what it is? So read until space. And then I read this into... Okay, so this is just changes how this works, which is going to be nice. Okay, so I want to do something like let mute raw method. So actually I can change this. So method. Can I actually just do this as a vector? Oh yeah, it actually needs to be a vector. Okay, so perfect. So we're going to do request, read until you get a space. We throw the method in there. And now we have all of you in there. Okay. Do you have a return a result? So we'll context reading I guess like getting method bytes. And then method try from method. Okay, I think that works. And so theoretically, this request reader is now up to date, like location wise in it to that first space. So we should be good to go with everything else. Okay, so you're missing path. So now I want request from state. Did I not put in go until definition? Oh, I didn't. Okay, so this will be path next. Okay, there's a path. And then I want to say path is equal to we need to do this. We need to actually implement it. So you have parse method from request. And so next would be function parse path from request. So we're going to have a request, which is our reader, and turn a result with a string inside. Let's see. What are we looking at? We are looking at starting from here into our next space. That's pretty much what it is. We're just looking for the next space. Spaces are not legal in paths. Is true, except technically it is possible to put a space into. Okay, it is not legal to put a space, like a real space, into a URL when you're passing that to a server. You're supposed to HTTP encode them. So if they do that, then sucks to be them. And by them, it means me. So sucks to be me. All right, so I want another space here. And then we're going to essentially copy. We're going to be very close to this. So we're going to have let mute our, give me the raw path. Need the path bytes. It's going to be an empty vector. Then we're going to say, okay, for the request, we want to read until you get a space. The method, sorry, path bytes. So this is parsing path from request. Okay. Once we have that, then I just turn this into a string. So we're going to return okay. String from UTF-8. Path bytes. Context. Converting path bytes to string. Okay. So now parse path from request is set up. So I should be able to do parse path from request and it the reader context parsing path like that. Okay. Okay. Right. Used binding path is possibly uninitialized because I need a loop through this to do it multiple times based upon where we are with this. So I probably just wanted to use an infinite loop like this. We have to match the state that we're in. We're going to get the method and the path, and we're going to set them out here. And then after every single one that we do this with, so if I do method, I probably want to call next on this and like move through and get the next one. Or we just say like, hey, we did the method, now time to get the path. So I could, my state is not mutable, but if I make you mutable, I don't want to call this next. I think that looks a little bit weird. Is this website recommended for somebody still in college, BTech fourth year? It's a little bit expensive for college, I would say. Unfortunately, Rohit. Also, hello. How are you doing today? But yes, you can absolutely put these projects in your resume, and you can. I would probably try to find like some flair to do with them, so it's not exactly the same. But I don't think enough people are doing CodeCrafters that you would basically look it, because everybody does like a to-do app, right? Like, so you can't put a to app in your resume, but with something like this, you're like building, I made an HTTP server. Go ahead and do that. I would also try to put some flair on after you're finished the project in order to make it yours just a little bit, because then you can also say like, hey, look, not only did I follow the challenge, I added my own thing to it, further trying to cement that you understand how this entire thing works, how the server works. Does that make sense? Okay, parse state. What are we calling this? Like we could do next state. So move on to self. I don't want to return anything. Ooh, I could do so we can have it done. So when we're finished, so we can say, let's match on self. So if we are self method and we run this, then I want the next one to be a dereferenced self is now going to be self path. Like that. If we're self path, then a dereferenced self is going to be equal to a self. All right, so we need to see what are all the different things we're going to get out of here. So we have method, path. I mean, we'll probably have like query and other stuff. is that protocol? So protocol headers body. So protocol headers body. Protocol headers body. Okay, so self path that goes into then protocol is next. Self protocol goes into. Oh, and since I'm doing this like that, let's just do this. Now you can be self headers. Okay, if we're self protocol. Okay, so if we're headers, we become self body. And if we're body, we become self done. Oh, and then done. Self done. And then in this case, I want to panic. I have not, I don't know if I want to panic. So I shouldn't call self on self, like next state on done. If I do, what do I want to do? Like there's so many different things. I want to go back to method. I could just stay undone and just nothing happens. Or I could print something out saying like, hey dummy, you attempted to call next state on done, but that's not a good idea. That might be the best thing. So let's try like just standard out, or I could return a result. And this won't change anything, so we're okay there. Okay, so self, let's do like that. So if we're undone and we called this, I want to bail, and we're going to say cannot call next state when state is done. Okay, that makes you happy. We do that. We update you. So now I can do a next state. Okay, so we have our loop. We match the state in here. In method, I want to do your entire thing and then state dot next state. What are you upset about? Cannot mutate immutable variable method. Right, I'm missing. Okay, so hold on. Fail to match arms. It's never red. It's red down there. Oh, wait, I think I know what's going on. It's the loop. The loop is making things weird. Okay, so if we get to done, then I just want to break out of the loop. That's all I care about. Break out of the loop. And I was really hoping that I wouldn't have to do a builder, but I think I do. I think we need to do a builder there. Habany, I did not get to see your message, so sorry about that. But hello, how are you doing today? Let's see. RG Brewskis, hello, how are you doing today? We are constantly striving to improve our and your software development. The comma misplacement drives me a little nuts, not gonna lie. Which comma placement? I missed where exactly that was, so I don't know when you put that in there. Artemids, hello, how are you? What is CodeCrafters? CodeCrafters is a website that you can go to that has challenges. So here we can see, I'm doing the build your own HTTP server challenge right now. I'm using Rust, but they have all these different challenges that you can do. It looks like the build your own interpreter challenge is free right now. So that is something to check out if you don't want to pay for it. And then they support all of these languages. Note that they have like X number of stages on here. That means that not all of the languages are supported by everything, except I believe Rust, Go, and Python are supported by literally every single one of their challenges. They have them there. But yeah, that's what CodeCrafters is. Do I even need a loop here? The order of parsing operatives is deterministic. Oh yeah, that's true. I don't need a loop there. Yeah, that's a good point. Okay, so here we see a software engineer being overly complex when they don't need to be. Do I even need a state at all anymore? Probably not. Hold on, let's just start this over again here. What if I just do okay? This is going to be a request. Or I guess I could do here. Okay, let's do that method equals parse method from request. Pan it the reader context. Parsing method. Okay, then request, and we have method and path. Okay, yeah, I don't even need the state anymore. So all of this stuff that I was doing goes away, which is always nice when we delete code. Okay, much better. And so now we have our method and our path. We get that. We parse that out. We exit. We return out of view. We're looping inside of here. Right. Read the stream. That needs to be the loop. And then, okay, then we print the request. So we should now see inside of this. We should now see an error. Starting to listen, receiving incoming message, misspelled. About to read stream, looping while getting chunks. We read 88 chunks, got all the chunks, got request, parsing error request. Error status 1. Wait. Did that not print out the way I expected it to? I thought that would print that out, but parsing raw request was the last thing we got. this. Okay, so parsing raw request. Interesting, I didn't get parsing method or parsing path from request, so those didn't fail, right? If I do that, oh, you need to be debug mode. Yeah, I didn't see anything. Okay, nothing came out as part of that. Well, that's fun. Let's see. I'll wait until the ad break is done before I continue chatting with chat. Okay, so what is going on here? Now, parsing raw request. I attempt to do the use. So, we don't get these out here, but I'm wondering if maybe there's something weird going on with this. So if I do like more print lines, because we love those. So we're about to parse method. Now, I believe that works, right? It's about to parse URL. Hey, welcome back, everybody. Okay, so what do we miss? So we talked about CodeCrafters. Perfect place for an M dash, which I don't think I did. Do you even need a loop here? Yeah. Okay. So I took out the loop. Welcome to Brooks Builds, where we are constantly striving to improve that's what you mean, and your software development leadership and productivity. Okay. Good point. I will try to remember. So add m dash to, I guess, like that's my Twitch about, and then in my note, that is, and your, wouldn't the M dash be like soft, and your, okay, now I'm questioning my ability to do any English at all, because none of that sounds right anymore. I'll do that for right now. That's a pretty cool challenge. Yeah, I think a lot of the challenges that they have are pretty cool. All right, so I've got this all up and running. We added some print lines in here. Let's go ahead and run you. Okay, about to parse method, and that was it. And then we had parsing raw request. So about to parse method, which means inside of here, we had an error. So read until space. So this is print line, I guess, like a reading method from reader. And then there's the try from. So it could be there too. So print line, converting bytes to method. Ooh, so I got to the converting bytes to method, and this try from failed here. So that makes me curious. Can I look at method string? Method string get. Okay. So we can actually see method string get. You could change the try from to pattern match the bytes directly. I could. Yeah. I mean, that would be the fastest way to do it. And probably the best. But okay, so the method string get like that, which means that, hold on. I think I know what the problem is. It's a space. There's a space. Trim just gives me a stir. So I can replace as stir with trim. And then that should hopefully work. There we go. Now we have exactly what we want. So fun fact, changing the pattern to match wouldn't have worked because there was that extra space in there that we had gotten. I just trim here and then we're fine. Okay, so now we have access to the request method and path. Now the same for the path. Yeah, because the path has that space in there too. So let's do parse path from the request. Okay, so path bytes, string from that trim returns. Okay, go on. There we go. Now we have method get and path, whatever path I put it in. Like that. Perfect. Okay. Excellent. All right. So now we have enough. I'm going to stop working on like parsing now because we can now solve this problem, right? Which is if the path is not slash, we return a 404 error. So in run for stream, we want to set what our response is if it's a slash or an index to HTML. Try, can you put space in a URL and see if curl automatically encodes it? Oh, yeah, we could do that. Sure. Nope, wrong one. I want that. Let's do curl. Curl doesn't even hit the server with a space in it. Can I try quotes on it? No, malformed URL. So yeah, it curl won't even let me do that, which is nice. Yeah, it is nice there, but I wonder if we could use something like Insomnia to test it with the space, because maybe Insomnia does the wrong thing. So if I were to say, oh, this is mostly behind you. Okay, so go to what am I listening on? 4221. Okay, I want, just give me new request. Okay, HTTP localhost 4221 / okay, so path, let's double check that works. That does. It's gonna, okay, so it looks like Insomnia is going to encode it properly. And so we see that coming in here like that. So perfect. Okay, works as expected. And if I do multiple here, we get that. So I think it's working the way we expect it to. All right, so we have a request and we want to check to see if the request is for /, because if it is, then we do a 200, and if it is not, we do a 404. Now, if we were to hard code this in here, which, like, you know, isn't the best of ideas, but we can do that. So if our request.path, if that is equal to the equivalent of, actually, you know what? I haven't even tested this. If I just do like that, that's path is /. If I add a / onto it, path is /. Okay. So if path is just /, and that's all it is, then I want to send, so our response code we can set to be 200 by default. If you are not /, I want our response code to be 404. So really, okay, so if you're /, we're going to turn 200, else return 404. You don't need to be mutable. You need to be formatted now. And then you're going to be the response code. And then everything else is going to be exactly the same. So now when I hit this, if we curl to this, we get a 200 OK. And if we curl to anything else, we get a 404. So let's get rid of our one warning. Method never used. Oh, do we have to also check if it's a get? I don't remember if we do need to or not. I'm going to leave this as a, I'm going to say that this is okay for right now. But okay, let's test to see if this works. And then if it does, we have 20 minutes or so to refactor. All right, so in our library, we have first pass responding with 200 OK on /. Let's find out if this works. It took long enough for me to write that they spun down the whatever system that they're building all my stuff in. That's fun. Okay, so they built it successfully. It's now going to run our code. Okay, so it looks like the only thing, the problem was that the message was supposed to be not found. Yeah, you're right. Shouldn't it be HTTP 1.1 not found and not 404 okay? I mean, yes, if you want to be appropriate, yeah, it should be. Okay, but yes, you're right. It should be so that's the response code. And then based upon the response code, we should have a message. Now, this kind of makes me think that we should have an enum for response code. So like HTTP code. And so if we have something like okay, so we'd have okay and we have not found, right? And then we'd have an impl for HTTP code. I want to, you know what? If I want to toString this, I don't impl that myself. I do an impl toString for HTTP code. Oh, I could impl display. Oh, impl display for it. That's even better. Yeah, let's do that. Impl display, format display for HTTP code. Okay, so all we need to do here is we need to format this and then we write out to it. And let's get our, I guess we'll get the message, right? So we'll get, it's two things. It's the number and the message based upon these. So I kind of want to do this as a tuple type. So we can let, this will be the number, is that code number? Like number message equals, and then we're going to match on self. So we're going to have self okay. If we get that, I want to return 200 and okay, like that. I wonder if I need to turn that into a string. No, I probably don't. I don't need to turn that into a string. Self not found is going to be for a 4 and not, is it all one word? Was that what it's supposed to be? No, 2 words. So not found, like that. Okay. So we have access to number and message there, and now we're just going to write. The first thing I believe is the formatter, so F, and then everything else is the same, the way we expect it to be for like a print line. So we're going to write, that is how write works, right? Yes, exactly. It's exactly the same as print line at this point in time. Okay, so I want just the number, right? So we want the number space the message. Am I supposed to do a new line before now? I don't think so. I think that's it. Okay, so then I return you. You're okay. HTTP code. Okay, so we need to. I need to convert into the appropriate HTTP code. Which is response code equals, okay, so if you're slash, I want HTTP code, okay, else HTTP code not found. That gives you that, and then gives me, okay, then this display should work as expected, and then we should be fine. So if I run this again, so if we do our curl again here, we get not found, okay. Good thing I tested that. 404 not found. Okay, excellent. All right, that should be good to go then. So we're gonna now commit, and this is now also sending the correct HTTP message. Let's see if this works. It did not. Okay, so what did we do wrong here? Expected reason to be not found got not found space. I didn't realize that space wasn't supposed to be there. Okay. Well, there we go. Now we know. Removing extra space after HTTP message. Try again. There we go. Tests are passed. And we can see what the tests are. They passed in. Okay, so they passed in blueberry, and slash. And we got the 200 status code. Excellent. Okay, so looks like everything worked out just fine. And what would be next would be refactoring all this, because this is all inside of lib. And if we look at, we're at 153 lines, and most of these are just stuff that I've made for parsing. So that should probably all go in its own file. So that's what we're going to do next time, but it's 12:50. I'm getting hungry. I set this stream to only go until 1 o'clock or so. So I think what we're going to do is we're going to wait until next week and then continue on with this project and start with refactoring it on Monday. So with that, everybody, thank you so much for hanging out with me today. I will be back, as I mentioned, next Monday. I'm only doing one stream a week right now. I have a bunch of stuff that's happening during the week, so I don't really have unfortunate time to do everything else, to do multiple streams at this moment. But I'm hoping that we'll eventually be able to. I am not seeing anybody that I'm following who's doing something similar, so I will probably skip the raid. So in that case, everybody, again, thanks for hanging out with me. Have a great rest of your Monday. Have a great rest of your week. And I will see you all next time. Bye.